We're now going to talk about how to complete this enzyme reactions activity. First of all, write down the definition of each vocabulary term. Use your notes. Then if you can't find it, like you won't be able to find chemical reaction, then use Google for those. Next, you're going to use the cutout paper, cut out all the enzymes, substrates, and products. Or if you don't have a way to print this paper, then you can sketch this on a sheet of paper and take a photo when you're done. Here is part B, and here is your enzyme, here is your substrate, and here are the products. You will organize these in a very similar way to this example. It's not identical, but it's close. So you'll want to have your enzyme before, during, and after the reaction. So here's 3 copies of your enzyme. You'll want to have the substrate before it reacts, the substrate locked into the enzyme beginning to break apart, and your product separated after you're done with the reaction. So there's your substrate before, your substrate as it begins to break apart, and your products when you're finished. Then you'll need to label before, during, and after the reaction. You'll need to label that this is an enzyme substrate complex made of a very complicated molecule of a substrate and an enzyme. You'll need to label the active site, and if you're sketching it yourself, you'll need to label the enzyme, the substrate, and the products. Otherwise, if you cut and paste, those have already been labeled for you. Part C is very similar to Part B, except this time the enzyme will put together the substrate into a single product. So we have the enzyme, we have 3 substrates, we have the substrates coming together and to form a single product. So this time you'll put your enzyme here, you'll put your 3 substrates here, still have your enzyme substrate complex, and then you'll have a single product here. Do all the labeling just like Part B. Finally, Part D. Use this table and graph the temperatures. So at 5 Celsius, we have a reaction rate of 0 moles per minute. A mole is just an amount of your reactant or product. Notice that the reaction rate is on the y-axis and the temperature is on the x-axis. So we want 5 Celsius and 0 for the rate. So here's Celsius, so go here. Let's see, if this is 0 and this is 10, and we have 1, 2, 3, 4, 5 spaces between them, each space must be 2. So this is 2, 4, 6, 8, 10. So if this is 4 and this is 6, 5 is right between it. Then we had a rate of 0 on the y-axis, so 0 and 5, and put a dot. At 10, we also had a rate of 0, 10 Celsius, 0 up. Let's skip ahead. When we get to temperature of 35 Celsius, we have a reaction rate of 25. So temperature of 35, reaction rate 25. Continue graphing until you've graphed this entire set of data. Then connect the dots with a curved best fit line. Don't connect the dots with straight lines. Make one arching curved line that fits very well. Then you will answer, what's the optimum temperature? You'll find the highest point of that curve, go straight down, and read the bottom temperature below, and that will be the optimum temperature. Don't forget to describe the line you drew and what happens as temperature increases. Also, don't forget in parts B and C, use the above terms and equation, using as many vocabulary terms as you can, explain what happened, and write your explanation on the paper where you either did your cutout or your sketch. Then, on part C as well, explain what happened using as many vocabulary terms as possible. You'll probably write several sentences.